In this video, I'm going to demonstrate solving a formula, an equation, but a formula for a particular variable. And this video is being made in response to a student request via email, and I appreciate that very much. And one of the things the student said in the email is, as they were approaching the problem like this on homework, is she was trying to follow the order of operations and work from the inside out, and it just seemed like you're getting stuck with that. Because if you start on the inside, you've got a minus 5, but you can't add 5 to this because it's stuck inside here. So when you are looking at solving an equation for a variable or solving a formula for a variable, almost just kind of look at the big picture and think, okay, what can I do from the outside? And you do have to abide by the order of operations, but maybe we don't have to just do all parentheses first and then all exponents next and so systematically. It does require us to think a little more flexibly, flexibly a word? In a more flexible fashion with our order of operations. Alright, and I do also want to say this before we start. There's not one correct way to do this. As long as what you're doing is mathematically correct, it is fine. So when I look at this and I'm trying to get the A out, I look at, okay, what's being done in the big picture sense? And I just see this dividing by x. Alright, so how do we undo dividing by x? Well, we can multiply by x on both sides. Now we are assuming, of course, that x can't be 0 because you couldn't divide by 0 there. So that's an understood fact there. So I now on the left side have m times x equals, I want to think of maybe, since I have a fraction on the right hand side, as this x being divided by 1. X divided by x is 1. And then that leaves me on the right hand side with 3 times the quantity 1 plus r times a minus 5. Okay. I have a couple of different things I can do here. I could distribute my r, I could distribute my 3, all that is fine, but I'm kind of looking again outside in. I know that's counterintuitive with the order of operations, but as long as we are applying processes correctly, we're okay to do that. This 3 is multiplying this whole business. So to get rid or to undo multiplication, the inverse operation of multiplication is division. A while ago I had division, so I used multiplication. Now I've got multiplication, I will use division. So I will divide by 3 on both sides. Now I have m times x divided by 3 is equal to this 3 divided by this 3 is just 1, and I'm left with 1 plus r times a minus 5. Again, a couple of different options for steps at this point. I could distribute my r, or, I'm working my way towards this, but I see I have this 1 here. Alright, that's a positive 1. And this is an addition situation. Alright, so that's a positive 1. To undo that, the inverse operation of 1 is subtracting 1. I'm trying to, I hate to use the term get rid of, but in a sense we are. I'm trying to turn this into a 0, more or less. So I will do that by subtracting 1 on both sides of my equation, leaving me with mx divided by 3 minus 1 is equal to, now 1 minus 1 is 0, r times a minus 5. Okay, so here we are. Now, you can also ask, well, should we combine that so it's one term? You could, but it's not necessary. Our goal is to just end up having a by itself, and it doesn't matter how ugly it looks on the other side, it'll be okay. Alright, so here we are, we're at this step, and we're getting very close. Now you might think, well, couldn't I add 5 at this point, and that'll turn that into just a? Remember, this grouping is being multiplied by r, so we cannot add 5 yet. Instead, what we'll want to do is we'll want to either distribute this r through that's an option. Or we could just go ahead and divide by r on both sides. So we've had a variety of options all the way through. Here I'm actually writing out what our options are with that. I would probably, if it was me, just on my own, I would go ahead and divide by r. But it is going to create a complex fraction, which we talk about in section R.4. So I think I'll just distribute in this video. Either way works. And that can be annoying. Like, can you just tell me the right way? There's not a right way. So I think, part of pre-calculus as we head toward a calculus mindset is this ability to think of different approaches and how they are all correct. So, hey, you're just so smart, you got to be able to process all these things together. All right, so we have mx divided by 3 minus 1 is equal to r times a is ra, r times minus 5 is minus 5r. All right. Again, let's not lose sight of the goal. We're trying to get a by itself. All right, I have 5r being subtracted from it. To undo that, I would like to, let's go with purple, add 5r on both sides. So I have mx divided by 3 minus 1 plus 5 times r is equal to r times a. I'm close. I'm very close. We want that a by itself. What's happening to the a? It's being multiplied by r. All right, so how can we undo multiplication? We looked at it a while ago. We will use division. So we can divide on both sides by r. We've still created this complex fraction. We just put it off a little bit. A is equal to mx divided by 3 minus 1 plus 5r all divided by r. This is complete. So you could stop right there. That is a correct answer. But if you don't like having complex fractions, and who really does, we could address this by saying, okay, so now we're just kind of simplifying our answer. This process here is optional. Dividing by r is the same as multiplying by 1 over r. And if that's, you're like, what is that? How can that be? Think about if r was 2. Dividing something by 2 is the same as taking half of it. So I always think that's a good way to kind of process that. Oh, okay, dividing by r is the same as multiplying by 1 over r, just like dividing something by 2 is the same as multiplying it by 1/2. So I could say we have mx divided by 3 minus 1 plus 5r. Dividing by r is the same as multiplying by 1 over r. All of this is still equal to a. I will distribute my 1 over r times each of the terms. Distributive property there. Which leaves me mx over 3 times r is 3r minus 1 times 1 over r is 1 over r plus 5r times 1 over r. If you'll notice, my r's divide out and just leave me with 5. Okay? So now I don't have complex fractions anymore. I just have regular fractions. And you could even take it another step and get a common denominator. And I will show you that. I won't talk you through it because I think I'm running a little long on my video time. But I'll show you what that looks like as well. But just recognize that here in yellow that's a correct answer. Here in green this is a correct answer. And then I'll show you my last answer in red to signify that I will stop. Thank you for your request.